Alright, so welcome back guys to a new video. So in this assignment, we will use the German credit dataset. It's a very common dataset. You can read more about it on internet. Basically, this is used to minimize loss from the bank's perspective. The bank needs a decision rule regarding who to give approval of the loan and who not to. So an applicant's demographic and socioeconomic profiles are considered by loan managers before a decision is taken regarding his/her loan application. Now the German credit dataset contains data on around 20 to 21 variables. There's another version of it which has 62 variables that we will use later in the future assignments. And this dataset is used for the classification whether an applicant is considered a good or a bad credit risk for 1000 loan applicants. So we will start by reading the dataset using the read.csv function as shown here. And then store it in a variable called German_credit. Now we will move to part A, which is asking us to generate a random sample of 500 observations from the German credit data and then save it as a data frame. So we will use sample command here to generate our sample. By the way, sample can be generated in many ways. We'll see different methods of doing it in our assignments as we move along. Okay, so in sample command, the first argument is the vector from which the sample is to be generated. So we are using a series of numbers from 1 to 1000, which is equal to the number of rows of our dataset. Next argument is the sample size, which is 500 in our case. And finally, we could also mention whether replacement is true or false. By default, it is considered as true. After this, we will use the output of our sample command, which will be a sample of 500 numbers between 1 to 1000, and then subset the rows based on those numbers from the German credit data. So that is how we generate a random sample from the German credit data of 500 rows. Now we will move to the next question, which says generate univariate profiles of the data using the summary function. So univariate data profiles are nothing but measure of central tendency and dispersion. Therefore, it means mean and standard deviations to be found here. So first we will separate the numeric variables of our samples and store it in a variable called German_num. Here we are using sapply function to find the variables that are numeric. Output of sapply will return true or false for each of the variables, and then we will subset our sample using the true values. So that is how we find the numeric variables using sapply function. Now once the numeric values are subsetted, we can use sapply again to find the column-wise standard deviation as shown here. We have stored the standard deviation in a variable called SD. Now for mean, we can use sapply again in the similar way, but we will rather subset it using the summary output as shown here. We are simply using summary command for our dataset German_num and subsetting the fourth value of the output. Because if you run the summary function, the fourth value of the output of the summary function for each of the column will be the mean. And the output we are storing in a vector using the C function. So using the C function, we are creating a vector of mean, which we are storing in a variable called mean_non_num. Finally, we will have to put the results in our data frame. But before that, there is a small problem that we need to tackle. So if you see the results of the variable mean_non_sum which we have just created, the results are displayed under quotes and written as mean, then a colon, and then the value is printed. So to create the data frame, we must remove the word mean and the colon sign. Now as you can see here, to do this we will use gsub function. Gsub function is used to replace certain characters from the data frame, vector, etc. The first argument would be the pattern that is to be replaced. So in our case, we need to remove the word mean and the colon sign. In the second argument, we will mention the symbol with which we want to replace the pattern which is mentioned in the argument 1. So as you can see, here we are using quotes to replace the first argument. And then the third argument is the vector or data frame from which this replacement needs to be done. So in our case, it is mean underscore non underscore num. After this, we will run this and we'll get the result as shown here. Alternatively, we could have used sapply function here and avoided all this trouble. But here I am trying to show you different ways of doing the same thing. That's how you learn things within a context so that it will last longer and you can remember this easily. Because you can go on learning the commands of R, but unless you have used them in a context and you know its use, you won't be able to remember them. So that is my approach and I find it a bit easy. So I hope you are also finding it useful. Now if you see below, I have given the explanation of gsub function that I just explained. So if you didn't get anything, you can just read it again. Now coming back to the problem, we will create a data frame and combine both mean and standard deviation in it. So we will use data.frame function along with the cbind function. So as we know, cbind function is used to combine columns or vectors. So we are combining two vectors, sd and mean. And then we have mentioned quote is equal to false. Generally, we don't have to mention this. But since we have subsetted the mean from summary command, the type of summary output is character. If we don't mention quote is equal to false, then any character present in data frame will be surrounded by quotes. So that is the reason we have mentioned quote is equal to false here. Now we will run this function and then we can see our output. But one problem here is that there is a third column that is created which mentions quote is equal to false. Now we don't need this column, so we will remove it by subsetting first two columns. So we can simply subset the data frame using the square brackets as shown here. So we have done this subsetting already many times. Now I'm not going to print the output. If you want, you can print it for yourself. But basically the third column will not be printed if we print this output. Now moving to the next question. It says generate pairwise correlation plots of numeric variables. So we can simply use cor function to generate pairwise correlation as shown here. However, it does not look good and it has so many repetitive values as you can see here. Now just imagine if we have a big data set with more variables, then how clumsy this table would look. So if you see here, we have values at the intersection of default and default. But why do we need this value? Similarly, moving to second column, we have correlation value of default and duration. But if you refer to second row and first column, we again have duration and default. Hence, it's a duplication and we don't need duplication. Ideally, we should only get the values at the intersection of the two variables. Now to remove this duplication, we will use a for loop to generate a correlation matrix which will only print the pairwise correlation between variables and remove any duplicate values. And after generating the correlation matrix, we will plot it. So now let's see how we can generate a correlation matrix which does not have any duplicate values. First, we will create a null matrix of 8 rows and 7 columns. As we have 8 variables, so there will be 8 rows and there will be 7 columns to display the pairwise correlations. Then we will define a variable counter as 1. After that, we will start the first loop, which will run from 1 to 7. And then we will nest this loop with another loop, which will run from counter to 7. Now you may ask, why from counter to 7 and not from 1 to 7? So the answer is because we don't want to include the duplicate correlations. Suppose if we have calculated correlation between variable 1 and variable 2, then there is no point of calculating correlation between variable 2 and variable 1. So if we have 8 variables, we will calculate correlation between variable 1 and rest of the 7 variables. Then we will move to variable 2 and include rest of the variables excluding variable 1. Because we have already calculated correlation between variable 1 and variable 2. So this is how we are going to proceed. So every time when the loop will run, the counter value will be incremented by 1. So in the first time, when the loop will run, the counter value will be equal to 1. In the second time, the counter value will be incremented by 1, and hence the second loop will run from 2 to 7, and so on. Now we will initiate our loop, and we will store our results in matrix that we have created earlier. So we are using correlation command here. It will take two variables as the arguments. For first argument, we will use k to subset the variable, which will remain the same for entire loop. So when k is equal to 1, we will have first variable, and it will be used for the entire second loop, for which L will vary from 1 to 7. Now the first time k will be equal to 1 and L will run from 1 to 7. So we will get correlation between the first variable and the remaining 7 variables. After completing the second loop, we will come out of that loop and increase the counter by 1. Now the second time the value of k will be equal to 2, and this time L will run from 2 to 7 because the value of counter is already 2. And that is how this entire loop will run, calculating the correlation matrix. Now once our matrix is created, then we'll give names to columns and rows. We will use colNames function to give the column names, and we'll use rowNames function to give the row names as shown here. After this, we can print our results. And now you can see the correlation matrix and can spot the difference between the earlier one and this one. So again, I could have just skipped this loop and made it simpler, but that is not my goal. I wanted to keep on introducing new concepts through these assignments. So that is the reason we have created this loop. Otherwise, there was no requirement for creating this loop. We could have simply used the correlation function and have got the results. But I hope this way you have learned something new. Now moving to the next part that says generate correlation plot using Corr rplot library. Now this Corr rplot library is a library which is built in the package Corr rplot. We will use this package to plot our correlation plots. So first we will have to install this package using install.packages function. We will mention the package name within the quotes under the bracket as shown here. Now I have put a hashtag sign before the function because I have already installed this package and I don't want to run this command again. But you don't have to put the hashtag sign because you have not yet installed the package. So once the package is installed, we will remove the NA values. Now if you see the output of the matrix that we had created earlier, it has returned NA against all the duplicate values. So to plot this matrix, we will first have to remove these NA values with 0. So we can remove the NA values as shown here. We will first check the NA values using is.na function and then subset those NA values using the square brackets. And after subsetting it, we will equate it to 0. So this way NA values will be replaced by 0. After this, we will install the library Corr rplot as shown here. And then we will plot our correlation matrix using the Corr rplot function. So the first argument would be the matrix that we had created earlier. And the second argument would be the method, which is equal to circle. Basically the type of symbol that are required in the plot. So we need circle, so we have mentioned circle here. We will run this function and we'll get our plot as shown here. Now this is a nice and colorful plot. Now here the size of the circle denotes the intensity of the correlation. So that is how we plot our correlation matrix. Now we will move to the next part that says generate bar charts of categorical or factor variables. So here we will use simple bar plot command coupled with sapply function. And in the sapply we will write our own function. So let's see how are we going to do it. Now the first step is to separate the categorical variable. So we can do it in the similar way as we did it for separating the numerical variables. The only change here is that we will mention the is.factor function to separate the categorical variables. Once we have separated the categorical variables, then we will use bar plot function. So for bar plot to plot the bars, it just needs the count of the category or class. So we can find the count either using a loop and store it in a variable, or we can simply use sapply function. So this time we will use sapply here. First argument would be the data frame. Then in the second argument, we will write a function. We can write a function by simply using the function command and write x within brackets. And then write the formula which is to be used in the function. And then close the brackets. Now whatever input variable we will pass through this function, our function will carry out the operation as given in it. Now within brackets we have mentioned x, then use the function unique, and then again use the function length. So whatever input variable will pass through this function, it will calculate the length of unique categories in that particular variable. So that is how a function is written. This is a very powerful tool and it gives us freedom to write any function based on our requirement. Now rest of the arguments are standard additional arguments for bar plot. So beside is equal to false means we want bars in the plots not adjacent to each other. So for colors we are using rainbow function and just mention the number of colors that are required. So what rainbow function will do, it will randomly assign colors to each of the bar. We could have manually assigned the colors as well. Then we have mentioned the title of the plot and the title of y-axis. After this, we'll run this function and we'll get a nice bar plot as shown here. Now moving to the next question. Here the question is asking us to write a brief summary of the data. So you can see here I have written a brief summary. You can also come up with your own conclusion. It is something that I have concluded. So here I have mentioned that the dataset contains information about 1000 customers. The information is pertaining to their bank account, their credit history, present credit situation, their credit purpose, property, installment, age, sex, personal status, employment, residence, etc. The variables in the dataset are integer as well as factors with multiple levels. This data can be used to understand the customer's credit history, and one can conclude about customer's credibility rating. The customer credibility rating is useful for the banker to decide whether the loan approval is to be given or not. So this was just a brief summary and it was just to test our understanding of the data. Now we'll move to the next question and see how do we build a simple linear regression model. So we will use lm function to regress amount on duration. Here the dependent variable is amount. And then we'll summarize and interpret the results. So as you can see, we are using lm function in R, which is an inbuilt function in R to build linear regression models. So here we are regressing amount, which is our dependent variable, onto duration. So we will write amount, then the curl sign, and then duration. So that is how we write the argument for lm function. Then the second argument for lm function will be the data. In our case, it will be German_num. We can add more optional arguments, but for now we'll keep it simple and just run this and our model will be ready. Now we can use summary function to see the summary of our model. So as you can see, summary is printed here. So we can interpret the results as follows. First we have the regression equation printed. Then 5-point summary for residuals is given. Then our coefficients are printed. we have intercept value as 81.66 and coefficient as 150.924. After that, we have standard error, t-value and p-value printed along with it. Now the interpretation of the coefficient is that for every 1 unit increase in duration, the amount will increase by 150.924. Now the t-value given here tests the hypothesis whether beta 1 is 0 or not. Now recall, in the linear regression, we studied that we check the hypothesis to see if the coefficient is 0 or not. Then only we get to know whether the dependent variable is actually dependent on the independent variable or not. So the t-value given here checks the hypothesis whether beta 1 is equal to 0 or not. And using the p-value associated with it, we can make a decision to reject the null hypothesis or not to reject the null hypothesis. So in our case, p-value is less than 0.05, which is our significance level. Therefore, we reject the null hypothesis. After the coefficient, we have significance code. We use this significance code to decide upon the importance of the variables. We will see this later on. After that, we have residual standard error, which is equal to 2187 on 498 degrees of freedom. And then we have multiple r squared, which is basically r square, and it is equal to 0.4104. And we also have adjusted r square, which is equal to 0.4092. And then we have f statistic, degree of freedom, p-values, etc. So that is how in a nutshell you interpret the results of linear regression. We will see this in much more details in the upcoming assignments. But that is all for now from this assignment. So let's just quickly refresh what we have learned so far. We first generated univariate profiles. Then we calculated correlation matrix pairwise using for loop and then plotted them. After that, we have plotted bar plot for categorical variables. This time we use sapply function and learned to create a customized function. Then we wrote a small summary about the data. And finally, we created our very first linear regression model and then interpreted its results. So that will be all for now. We'll see more of linear regression in the next few assignments and expand our model building capabilities. So thank you for watching the video. I'll catch you up in the next video now.